Hey guys, welcome back to Math 100. This is 2.2 operations with sets. This is the second day we're spending on set theory. Set theory is just a theory about sets. Last time we learned what sets were. Sets, remember, are just collections of things. And it's a collection that's well defined. That means you know if it's in the set or out of the set. An element can either be in the set or not in that set. We also learned about subsets. We learned about how to denote sets using roster notation or set builder notation or descriptive notation. And we learned about cardinality. This is the number of things in a set, right? And then we also learned about the empty set, what that was, and equal or equivalent. That was last time. If any of those concepts are unfamiliar to you, then just go back and rewatch 2.1. Okay, today we're talking about operations with sets. And what you'll see is that operations with sets is kind of similar to operations with normal numbers. With normal numbers, we have like this whole thing called algebra, right? And we have like plus and minus and different operations like multiplication, division. In operations with sets, we have something similar but more suited to sets. We'll get into what that is as we go along. First, let's talk about this definition right here, the universal set. So what is the universal set? The universal set is the set of all elements under consideration in a given discussion. So in other words, it's the universe in the context of whatever sets you're talking about. So the universe could be the set of all numbers, but it could also be something else. It could be the set of all people, let's say, if you're interested in only looking at sets of people. Now let's draw some general Venn diagrams, starting with just the most simple one, the set of A, or, A is just a random letter that we chose. It could have been any other name, but we're just talking about one single set. So let's start with a picture of it. Okay, this thing is supposed to clean up my rectangle for me. There we go. Okay, so this box represents the universe. I'm going to label with the U to indicate that's the universe. And within the universe, there's some set, and that set is named A. So that's the picture here. This is the general Venn diagram for a single set. And we'll just label that with an A. We can also add some shading to indicate, just to be extra clear, that's the set I care about. That's what I'm talking about. I'm shading that. I'm indicating that set A. I went over the line slightly, but you get the idea. Okay, so that's the set in question, set A. Simple picture, yeah? Okay, second is the complement. And I'm going to draw this picture for you. As I draw this picture, we're also kind of learning the intuition behind what the operation of the complement does. So that's the first operation we're looking at, complement. Okay, so here's the universe, right? In that box. Here's my set A. The complement is everything outside of A. So I can even label it like that, A complement. We denote the complement, as you have gathered by now, by this little bar at the top, yeah? And we read that A complement, or the complement of A. We can also say not A, because that's everything that's not inside of A. Yeah, and so let's shade to indicate which part we're talking about. We're talking about everything that's not inside of A, so everything else. I'm going to go over the line a little bit, I think, because I'm just not that good at shading perfectly, and my highlighter is a little too fat, but you get the idea, right? We're just shading everything that's not inside of that circle, because that circle represents A. So A complement is everything that's outside of that. Okay, sweet. Okay, 3 and 4 are basically the same picture as each other, but in different directions. So if you look at number 3, it says A is a subset of B. That's what we learned about last time, right? The idea of a subset. So, I forgot to mention this, but you guys should really be trying this on your own before I give you this answer. So try to draw what you imagine would be the picture of a subset before I finish this picture. So here's the universe. Here's my set A. And then here's my set B. And A is a subset of B. That means A is the smaller one, right? And it exists completely inside of the bigger one if it's going to be a subset. So that's the picture right there. Now, if you're wondering why I'm alternating colors, don't pay too much attention to the colors. I just did that so that you don't get confused from problem to problem. We don't get mixed up with each other between questions. Okay, number 4, B is a subset of A. So that one would be the exact same picture pretty much, right? With one small difference. Okay, didn't like my rectangle. It doesn't recognize my beautiful art as a rectangle. There you go. Okay, so here's my universe. And I've got one set that's inside of another set. This time the smaller one is the B, right? Because B is the one that's a subset. So B is inside of a bigger set called A. Okay, number 5, the union. Okay, this is the second real operation that we're learning. The first operation was this guy over here, the complement. Second operation is the union. And we sometimes read it as A or B. So we say A union B. We can also say A or B. Let me draw you the picture for that. Okay, I'm going to draw it off to the side a bit. Come on. Don't like my rectangle. There you go. Okay, so here's the universe. And you know what? When we draw a general Venn diagram for this, we have to draw a Venn diagram that's going to allow for all possibilities. And so this is the most general picture that you can make if you have two sets. You've got one set and you've got the other set with overlap at some point. Now I can't draw it like this separate, because what happens if they have something in common, right? Then I need to allow for the possibility that there's something in that center area. So you have to allow them to overlap. And even in the event that they don't have anything in common, that just means that nothing is in this area. And that's okay. So the most general picture for two sets should look something like that. And we'll label this one A and the other one B. And the union is just everything all together. So it's everything that's in A, it's everything that's in B, and it's also anything that's in both of them. So it's kind of what you would imagine if you had like two states and you take the union of them, like in the United States, it's everything all together, right? Now, why do we say or? Because a lot of people think that and seems more intuitive for the union. No, get that out of your mind, because you're going to get confused if you think of and for the union. It's not and, it's or. The reason why is because let's take some random object. And let's say random element, say. Okay, I have this element. Let's say he's right here. And I say, is he in the union? Yes, he's in the union because he's in A or B, right? If I put some guy over here, is he in the union? The answer is yes, because he's in A or B. What about here? Is he in A or B? And the answer is, if you have to answer yes or no, yes, because he's either in A or B, or possibly both. When we say union, or when we say or in math, we mean the inclusive or, which means we allow for the possibility to be in both. Now, this is kind of abstract at this point, so let me give you guys just a real quick example. Let's say A is the set of all KCC students. Okay, so A is all KCC students, and B, let's say, is a set of all 19-year-olds. All right, so in this area here, you've got KCC students, and they're not 19-year-olds, right? So these might be KCC students who are older, or maybe you have a couple that are younger. Here, in this area over here, those would be 19-year-olds, but they're not KCC students. And then here in the middle, you'd have the 19-year-old KCC students, right? So if I was to ask a yes or no question for each of those categories, here's a 19-year-old. I'm sorry, no, here's a KCC student, I mean. Is he in the union? The answer is yes. Is this person in the union? Answer is yes. Is this person in the union? The answer is yes. The only people who are not in the union are these guys out here. In the context of our particular A and B, those would be non-19-year-old, non-KCC students. So people who are not KCC and they're not 19-year-olds. Okay, let's move on to the intersection. So the intersection is kind of like what you expect it to be, I think. Like if you just think of the word intersect, what does that mean? Intersect means where things overlap, right? So here's again our universe. And again, we draw the most general Venn diagram. That means we're going to allow for them to overlap possibly. Doesn't accept my circle. There we go. So here's A again, and here's B. So the intersection would be everything that's where they intersect or where they overlap, things that they have in common. Okay, so we'll shade that part right there in the middle. And this time we can read this as A intersect B, or A and B is another way to read that. Now, why A and B? Well, to be in the intersection, you have to be in A and you have to be in B. Whereas to be in the union, you just have to be in A or you have to be in B. Those three spots, okay? Okay, so yeah, looking at the context of our previous example, that would mean only the 19-year-old KCC students are in the intersection. All right, lastly, we're gonna finish this page in this video with this Venn diagram example. So I'm gonna do this one for you. On the next page, when you guys do problems, you're gonna have something similar. So here's the setup. We have the universe told to us as just these letters, A, B, C, D, E, F, G. Sorry, let me change colors. I don't wanna mix up with my previous answer. So here, our universe is just A, B, C, D, E, F, G. We have a set A, which is A, B, and C. And we've got a set B, which is A, C, E, and G. Okay, so our task is to make a Venn diagram for this situation. So we'll start by making our universe box. Come on. Come on. There we go. Oh, it thinks that's a square. Whatever. Square's good enough. Okay, so here's our universe. We're going to draw the most general picture. So here's A. And here's B. They might have some overlap, right? And we'll go through each of the elements in our universe one at a time and try to figure out where they belong. As usual, guys, try this out by yourself before you watch this answer. Okay, so let's start with A. Where does A belong? A is inside of the set A. It's also inside of the set B. So that puts it in the intersection of those two right here. Oh, I forgot to label these sets. So this is set A here. This is set B here. Okay, so that was A. What about B? Where does B belong? Well, B is inside of A. But it's not inside of B, so that would be right here in that spot. Yeah. C is inside of A and inside of B. So again, that's right there in the intersection once more. Okay. Let's erase all that. Okay, what's next? Next we have D. D is in neither of them, right? So that means it's out here. It's in the universe, but it's not inside of A. It's not inside of B. All right. What about E? So E is inside of B, but it's not inside of A. So that puts it right in that spot, in that region. F is inside of neither of them. So again, F is out here somewhere in the universe, but not inside of A, not inside of B. And G is inside of B and only B. So G is right there. All right, so here we have a Venn diagram, just kind of illustrating this situation here, where here's your universe, got those letters. Here's your set A, and here's your set B. Okay, with that, guys, we have finished all the theory, basically, for this chapter, or not sorry, this chapter, but this section. In the next videos, we're going to tackle some problems. And, you know, as you do the problems, really, I think that's when you really start to get a firmer grasp of all these things we've been talking about. So I'll see you in the next video.